So chain rule. We know composition of functions, hopefully, from chapter 1. Yes. What is the composition of, say, f compose g of x? F of g of x. F of g of x. For two functions that are functions of x, right? F is a function of x, g is a function of x. Let's say we want to find the derivative of this. If I want to find the derivative of f of g of x, in other words, if it is function of a function, then we would use chain. Good. So anytime, so if we had u times v, product rule, u divided by v, quotient rule, function of a function, chain rule. Does that make sense? So function of function, which is composition. So I'm going to say that u equals g of x. And I would like to find the derivative of f of g of x. Good. I'm going to replace g of x by u. Didn't mean to cut. So f of u. So we want to take the derivative of f of u, but if you look at that, u is actually a function of x. So I can't take the derivative with respect to u, or that's what you will think. Because when we take the derivative of a function, it has to be with respect to whatever variable that you have. dy over dx, dy over dt, dy over dw, depending on whatever the independent variable is. In this case, the independent variable is u, right? One of the properties of derivatives simply states if I take the derivative d over dx of something that is not x, then it'll be a constant, then the derivative has to be 0, correct? The derivative of a function is never 0 unless the function is a constant. Good. So anytime you get an answer for a derivative as 0, then you are wrong. Unless the function is a constant, the derivative cannot be 0. Unless you have a term where the tangent is line. So you can't put this directly as 0 because u depends on x indirectly. Correct? U is not a constant. So f depends on u depends on x. So we can't put 0 because u is a function of x. If I call that y. That would simply be dy over dx. Agreed? So, just to make things easier, I'm going to multiply and divide by du. Did I do anything wrong? I guess no. No. All I did is I multiplied and divided by du, which means I'm multiplying by 1. So now I could rewrite this as du, dy over du multiplied by du over dx. Good. Since y is f of u, I can write this part as f prime of u. Do you agree? Multiplied by du over dx. U is g of x. The derivative of g of x with respect to x is g prime of x. Good. We want the answer in terms of x, so I'm going to replace u by g of x. Good. Now you may ask me, well, where did the chain rule part come into play here? Why did they name it as chain? So when I took the derivative, I took the derivative of f, which gave me f prime of g of x. Then I took whatever function that was composed, and I multiplied it by its derivative, right? One link of a chain. So if you had multiple functions, function of a function of a function of a function, you would keep on multiplying by the derivatives of whatever function you compose with, which is why we call it the chain. So if we have a function of a function, we take the derivative of the function multiplied by the derivative of the function that went into the original function. It might seem all confusing. When I do it using an example, it's actually easy.
It's like a Russian nesting doll.
What?
Russian nesting doll.
What?
Russian nesting doll. You take one out, there's another one in there. Take another one out, there's another one in there.
Great.
No, he has points. I actually agree with
He does have a point.
It's not a tangential point, it's an actual point.
So let's take a simple example. Suppose I said h of x is equal to x plus 1 squared. Correct? I am going to argue this is a composition of two functions. What are the two functions? Go ahead.
X squared, X plus 1.
Very good. X squared and x plus 1. Yes, no, maybe. So when I compose the two, g of x goes in place of x. Kicks that x out, and you end up having x plus 1 squared. Do you agree? Yes. Now, what does our rule state? It simply states I want to take the derivative of that function, plug in g of x, and multiply by the derivative of g of x. So this is what I tell students to do. For a moment, yes, Gio.
I was gonna say, yeah, like, but you make it like a variable. And so the two is like the derivative, so you put it in front. and
Yes,
multiply it by.
that's exactly what we did. We did by calling it as u. I wouldn't even go that far. For a moment, visualize in your head that the entire expression in the box is just x. Okay? The entire box, whatever it might be, it could be erase x, sin x, whatever. I'm going to visualize it in my head as x squared. What is the derivative of x squared? 2x. X But in my head, I visualized x to be the one in the box, right? So x plus one. What does chain rule say? Well, that's not the end of it. You've got to take whatever g of x that you had, multiply it by its derivative. That is g of x. The derivative of that is 1. Good? Does that make sense? I'll do one more case before I do another problem. So the derivative is just 2 times x plus 1. Here is the question. If we did not know chain rule, or you forgot it, how would you find the derivative of x plus 1 squared? Product rule, that's one way. Another? You FOIL and then take the derivative of each term. So 2 ways of doing it. Why is the chain rule beneficial? By all means, chain rule is the fundamental principle behind a derivative. Let's take another case.
So h prime of x is equal to.
Patient So h of x is now a composition of 2 functions. What are they?
X cubed
Annie, x cubed and
sine x plus cosine.
g of x is sine x plus cosine x. Yes? When you compose, this entire function goes in, kicks that x out, you end up getting sine x plus cosine x cubed. Correct? So f composed g of x is simply h of x, and that is sine x plus cosine x cubed. Good. What does chain rule say? For a moment, I am going to assume whatever that is inside the function that was used to compose as just x in my mind. So what is the derivative of x cubed? 3x squared. So 3 x squared, but in my mind, what was x? Sine x plus cosine x. Are we done yet? Yes. What goes next? Multiply by the derivative of that inside function. What is the derivative of sine x? Minus sine x. And that is in a compact, nice little form, right? It is in terms of factors. We want expressions if it is possible to write in terms of factors. That's why we learn factoring and all kinds of things in life. I can make this complicated. How can I make this complicated? Make it messy a little. Foil this, right? You foil and then multiply with cosine x minus sine x, and you get a very lengthy expression. Do you really want to do all that? No. I could put this directly in a calculator or computer and understand the behavior of whatever experiment or process that I'm studying. Well, that is how chain rule works. Suppose you had forgotten chain rule. How would you find the derivative of that?
First you would FOIL at the very least, first two terms, then you would FOIL what you get from the product from that to the original term. And then from that, you would find the derivative.
So you've got to FOIL this, right? And when you FOIL, you would get a sine cubed x down, cosine cubed. Where's the sine?
Just asking. Really quickly, the final thing, right?
First, you've got to rewrite sine x plus cosine x cubed. You can put this on the side. This is not required. I just want to point out why things could get complicated. So we will have sine cubed x plus 3 sine squared x cosine x plus 3 cosine x sine squared x plus cosine cubed x. Mind you, we don't know chain rule. So we can't find the derivative of sine cubed of x directly. So you have to use product rule here multiple times, product rule there multiple times, product rule there multiple times, product rule there multiple times. If you took this approach, it will probably take you about an hour to get it right. Do you really want to do that?
That's on the accounting, you're making mistakes along the way.
Yeah.
And the mistakes that you make along the way, which could take you about 3 hours to fix.
Okay.
So this is the most effective way of finding the derivative if you have composition for functions, yes.
So my question is at the very least,
Okay, so
thank you for.
we have x cubed plus x squared plus 9 base 5. If you did not know chain rule, how would we find the derivative? I'll just give up. Because you have x squared plus x cubed plus 9 raised to the power of 5. So you've got to FOIL and FOIL and
Pascal's triangle.
but still it's very complicated. So I don't want to do that. To find y prime, I am going to treat the function inside as x cubed, which is x cubed plus x squared plus 9 as x. If that is just x, what is the derivative of x raised 5?
5x.
5x raised 4, I know this is, or x is x cubed plus x squared plus 9, multiplied by 4, sorry, raised to the power of 4. Are we done yet?
No.
No, you've got to take the derivative of whatever that is inside, so you get 3x squared plus 2x.
And then you can take out the.
Derivative of 9 is 0. So 5 times x cubed plus x squared plus 9 raised 4 multiplied by I have x in common 3x plus 2. Here is the question. Could I write that answer as 5x multiplied by x cubed plus x squared plus 9 raised 4 times 3x plus 2? Yes, because I'm just multiplying, so the order doesn't matter. So of these two, what would a standard answer option would look like? It's going to look like that.
Which one?
You know, those will look like more clarity now.